Okay, this is the P4 paper from January 2024. It's question number 6. As we can see, this is a vectors question, and it's going to be a points of intersection question when we get into it. Right, let's have a read through. It says, relative to a fixed origin O, we've got these two lines, L1 and L2, which are given by what you can see on the screen. And it says, given that L1 and L2 intersect, can we find the value of P? Can we find the position where they meet? Can you find angles in between them, etc., etc.? Let's just concentrate on that part A, where the two lines actually meet. So we've got that the lines L1, I'm just going to write it in a slightly easier way, is 3 plus 2 lambda I plus P minus 5 lambda J plus 7 plus 4 lambda K. Just makes it easier to do the next part if I've got L1 written like that. And similarly with L2, I'm going to call that 8 plus 4 mu I. I'm going to call it mu minus 2 or minus 2 plus mu. It doesn't matter which way around you write it. Personal preference really with that. And then 5 plus 2 mu K. So if they meet, then these two can be made equal to each other. Let's just tell the examiner. If they meet, then L1 equals L2, which means I can look at each part, the component of I, the component of J, and so on, and equate all of those. So I can say 3 plus 2 lambda must equal 8 plus 4 mu, P minus 5 lambda must equal minus 2 plus mu, and 7 plus 4 lambda must equal 5 plus 2 mu. So normally when I do these, I just take the top of these two equations. I just take equation 1 and equation 2. I'd solve for these two equations. I'd work out my lambda and my mu, and then it'll always work. You need to then check it in this last equation, and if it works in the last equation, that's the only way you can then say there is a point of intersection. It will always work for 2 of the equations. We need to show it works for all 3 of the equations. Well, actually, because I'm trying to work out P and P is an unknown here, I've got no choice. I'm going to have to solve for those 2 equations this time, which I'll be able to do once I've solved for those 2. Because they've told me they intersect, I'm not trying to prove they intersect, I know they do, then I'll be able to work out P because it'll have to work in that 3rd equation. So let's just make it clear to the examiner. I'm going to say, oops, my highlighter. I'm going to say equating 1 and 3. Think about how you're going to lay these out. I lay them out hopefully so that I make less mistakes as I'm going through. 1 and 3 then, what have I got here? If I multiply that equation by 2, I'll end up with 6 plus 4 lambda is 16 plus 8 mu. And then when I have the other equation, 7 plus 4 lambda is equal to 5 plus 2 mu, I can then just subtract those from each other. I'm not going to spend any time talking to you about how to solve simultaneous equations. You should be able to do that. That's going to give me that mu works out to be equal to minus 2. Okay, if mu is equal to minus 2, then using the top one, 6 plus 4 lambda is equal to 16 plus 8 lots of minus 2 there. Then rearranging that, lambda works out to be equal to minus 3 over 2. Now, as I said earlier, that's always going to work in 2 of the equations. In order for them to meet, it has to be true in the 3rd equation as well. So here, check in equation 2. Now, that's why I labelled it. It just makes it a little bit easier to say what I'm actually doing here. So I've got that P minus 5 lambda, so P minus 5 lots of that, is equal to minus 2 plus mu, which is minus 2, not plus minus 2, so minus 2 there. So if I rearrange all that, P works out to be not the nicest of looking answers actually, minus 23 over 2. I'll sort of go back and have a check and make sure that is correct because I've checked the answers. But that's not very nice in terms of what P is going to be. But fine. Okay, so we've done part A, which says find the value of P. Now it says find the actual point of intersection. Now just be careful about what it says. It says find the position vector. Write it as a vector, not as a set of coordinates here. So where they intersect for part B, I can use either lambda or mu. They intersect. So just hesitating then, just thinking about how I'm going to write this down. It's 8 plus 4 mu, minus 2 plus mu, and 5 plus 2 mu, and I know that mu was equal to minus 2. So that's going to work out to be 0, that's going to work out to be minus 4, and that's going to work out to be 1. I want the position vector, so either written like that or minus 4j plus k. Either of those will do as a position vector, but it doesn't say the coordinate. Don't put 0, minus 4, and 1. Okay, that's part B done. What does part C say? So part C says find the angle between L1 and L2. Now, at no stage have I drawn this out yet because it's all been so straightforward, but we've basically got a situation, we've got a line L1 and a line L2 there. I haven't got anything complicated yet, so I'm not worried too much about doing this. To find the angle between them, what we're going to need to do is understand that A dot B will equal to A, B cos theta if we had vectors A, B, and we had vector theta there. When I'm talking about A and B, though, A and B are the directions of the two lines, okay? These are where they start off from. They're points on the line, but this is the direction of L1, this is the direction of L2. Right, don't need any of that, let's just explain it to you guys. Let's get rid of all that. So part C, just again, to make it clear to the examiner what I'm doing. So direction of L1 and L2 are given by 2i minus 5j plus 4k and 4i plus j plus 2k. So if I'm going to do that dot product business, A dot B is equal to modulus A modulus B cos theta. So A dot B is going to be 2i minus 5j plus 4k dotted with 4i plus j plus 2k. That's equal to the modulus of A, which is the square root of 2 squared plus, just be careful when you're doing all this. It's so easy to make a mistake copying things down or, forgetting a square root sign, anything like that. 4 squared, 1 squared, 2, I'm trying to do that one. 2 squared there, cos theta. So you can do this as quickly as you actually want to do. Here, I'd say that's 8 minus 5 plus 8 is equal to, and then I've got root of, 4, 25 and 16, that's 45. Square root of 16, 1 and 4, that's 21. Cos theta, you go straight to the answer really from here. If I tied it up a little bit, I could say cos theta is, that's 11 over root 45, root 21. But only in terms of my calculations, you wouldn't leave anything like that. If I do all that, that all works out to be, calculator 0.3578, ... There's more numbers there. Inverse cos, though, gives me theta working out to be 69 point, what did we say? 1 decimal place. So 69 point, actually works out to be 69.0 in this case. For that one there, so that's part C done as well. And then, what's the last part? It says, point A lies on L1 with the parameter lambda equal 2. Okay, so then I could work out what point A is. I could work out OA. Point B lies on the line L2 with AB perpendicular to L2. Okay, so we've got the idea that if I've got two lines, I'm not going to write any of this down for the examiner, but if I've got two lines that are perpendicular, and these are A and B, what I know then is that, that's 90 degrees there, A dot B will be equal to 0. Okay, so in this case, one of my lines is OA and my other line is AB. So I've got to find what OA and AB are, and then we'll do all of that. So if lambda is equal to 2, then L1 will be 3 plus 4i plus, minus 23 over 2 minus 10 j, and then plus 7 plus 8 k. So in other words, OA there is going to be 7i minus 43 over 2j plus 15k. I must admit, if I was doing this for the first time, I'd be a bit wary about my numbers there, but I have checked them. I know these are right. AB, well, AB is always B minus A, isn't it? So AB is going to be B minus A, so that's going to be 8 plus 4 mu I plus minus 2 plus mu j plus 5 plus 2 mu k minus the thing that we've just done. So 7i, let's do it properly, plus 43 over 2j minus 15k if we're taking it all away. Right, okay, so let's tidy all that up. Let's actually see what we've got there. We're going to get that works out to be 8 plus, well, let's just do it quickly. It's going to be 1 plus 4 mu. You can take your time and do this. I'll just put the answers in here. Plus, if we tidy this up, this works out to be mu plus 39 over 2j, and it works out to be 2 mu minus 10 k there. So we now know if perpendicular, then I'm going to say P dot Q equals 0 just because I've got A's and B's in my question there. But basically, these two dotted with each other should work out to be equal to 0. I'm going to use the iPad to help me that one, keep copying things out. So basically, that dotted with, oops, sorry, that, so this one dotted with this one. Oh, no, sorry, not that one. Just be careful. Well, there you go. There's mistakes that I'm making. It's perpendicular to the direction, that one there, the direction of L2, isn't it? So, oops, sorry about that. It's perpendicular to L2. So, AB dotted with that one is going to be giving me 0. So I just said just a minute ago about the way that you set these things out means that you're just less likely to make mistakes as you're going through. So sorry, dotted with 4i plus j plus 2k equals 0, and then just multiply all of this out, so you get 4 plus 16 mu plus 39 over 2 plus 4 mu minus 20 works out to be equal to 0. That will then give me what mu works out to be. So mu works out to be equal to minus 1 over 6. But what they wanted to do was they wanted to know point B, didn't they? They wanted to know the coordinates of B. So if mu is equal to minus a sixth, OB, remember, is 8 plus 4 mu I. It's minus 2 plus mu j, and it's 5 plus 2 mu k. Tidy up that I. And we know that lambda is equal to minus a sixth, so if we put that in, we get 8, what's that, minus 2/3 I, we get minus 2 minus a sixth j, we get 5 minus 2/6 k, and then tidying that all up, and as I've said this about most of the answers going through here, in the exam I'd be a bit worried if I got these values. This is actually correct, but I think the examiners could have helped us out a little bit by actually maybe saying show it's equal to something like that, and at least I would have been a little bit happier with what I've got. Right, now what do they want? They want the coordinates of that. So again, just check. B is 22 over 3 minus 13 over 6, 14 over 3. Always just check right at the very end. In fact, let's just change that we've actually got the answer to the question that they've asked. A lot of places where you might make a mistake with that, but a relatively straightforward vectors question. Hopefully that all makes sense.